Okay, welcome to this video. This is a bit of a different one. This was supposed to be what I was gonna do when we were live streaming. Unfortunately, that ended up not being able to happen because of technical difficulties. So I'm just gonna do this as a video, and this is gonna be it. I'm gonna go through the entirety of this paper. This is Mathematics Paper 1, Non-Calculator, Foundation Tier Edexcel. From 2017, so you'll probably have had some questions from this paper come up in like Maths Watch or just past papers and stuff. But I'm going to go through the entirety of it just so you've got like a good idea of some approaches that you can use in exams, that kind of thing, and just some general revision of topics from all across the board. Okay, let's begin. So let's find the pen. Brilliant. Work out the value of 2 to the power 4. Okay, so 2 to the power 4 means, oh, it's taking a little while. 2 times 2 times 2 times 2. Because that's what 2 to the power 4 means. It means 2 times itself 4 times. So we have 2 once, times 2 twice, times 2 3 times, times 2 4 times. 2 times 2 is 4. Times 2 is 8, times 2 is 16. So our answer is 16, and that gets us the 1 mark. Right, 7.26451 corrected 3 decimal places. So if we look at our 3 decimal places, we have 2, 6, and 4. But we're going to look at this 4th decimal place and see, are we going to round up or are we going to round down? Now it's a 5, so we're going to round up. So the 4, so we look at this 4 here, that becomes a 5 because the 5 from the 4th decimal place means that we round it up. So we get 7.265, and that is 1 mark. Simplify 7 times e times f times 8. So if we look at the e and the f, e times f is just ef. So we can just call that EF, and I'm going to rub that out and put it a bit easier to present. To read E F. 7 times 8. Now this you'll have to do in your heads or work it out. 7 times 8 is 56, and you can do that by doing 7 times 8, or just going up in your 7 times table, or you can split 8 into 2 times 2 times 2. 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. Or we can split that into 20 times 2 is 40. 8 times 2 is 16. 40 plus 16 is 56. So we have 56 times EF, and we just present that as 56 EF, and that is our answer. Right, solve x over 5 is 2.5. You see the one's a little bit off centre, but we're going to assume that says 2.5. So we're going to multiply it by 5 on both sides, because we want the x by itself. So we get x equals, now 2 times 5 is 10. Half times 5 is 5 over 2. 5 over 2 is the same as 2.5. So we have 10 and 2.5. That becomes 12.5. So x equals 12 and a half. Or, and you can work this out by multiplying the 12 by the denominator and adding the numerator. 25 over 2, because 12 times 2 is 24, plus 1 is 25. So you can put either of those as the answer. I'm going to leave it as a. It doesn't say what it wants, so I'm assuming you can put either. I'm going to put it as 12.5, because that's how the question, because it's an improper, because it's a mixed here, so I'm going to leave it as a mixed in the answer. 12 and a half. Right, 4/5 is a percentage. Okay, so let's do 4. No, wrong way around. Right, 5, 4. How many 5s go into 4? 0. So we carry that. How many 5s go into 40? 5, 10, 15, 20, 25, 30, 35, 40, 8. Remainder nothing. So now we have our decimal, which we multiply by 100 to become a percentage, 0.8. So we move the decimal place that way once, and it becomes 8, and that way once, and it becomes 80. 80% is our answer. And this is page 1 finished. I shall make sure I've been recording. Good. Let's go to the next page. Work out 60% of 70. So, let's work out 10% and then multiply by 6. That's always a good way of doing these kind of questions, especially if it's a multiple of 10 in the percentage. So if it's 10%, 20%, 30%, 40%, etc., you just find 10% by dividing by 10, moving the decimal place, or crossing out a 0, and then you just multiply by whatever you need to multiply to get to the percentage. So let's do that. 10% of 70 is 7. So 60%, we're going to multiply 7 by 6. So multiply that by 6. So we're going to multiply this by 6. 7 times 6, you can do with 7 times 2 times 3, so if it's a bit easier. 7 times 2 times 3. 7 times 2 is 14. 14 times 3. You can split that up into 10 times 3, which is 30, plus 4 times 3, which is 12. That gives you 42. So our answer is 42. And we've worked that out. Sammy spins a fair 4-sided spinner. What is the probability that the spinner will land on B and mark it on the probability scale? Right, so how many B's are there on our spinner? We have 1, we have 2. So we have 2 outcomes out of a total of 4-sided spinner. There are 4 outcomes, so we put that as a 4. You can simplify this as 1 over 2. Our probability is half. Mark with a cross on the scale. We mark it there, where the X is. In fact, I'm going to just make sure that's exactly right. So we're going to do an X there and an X there. So it's exactly on the half. Okay. What is the probability that the spin will land on F? How many F's do we have? Well, we have A, B, B, and C. There are no F's, so we put a 0 over the total, which is 4, and that just equals 0. So we're going to put an X right next to this 0, and that is the answer for this question. We've now got quite a big question. Fatima buys 2 packets of bread rolls costing £1.50 for each packet, 1 bottle of ketchup costing £1.60, 3 packets of sausages. Fatima pays with a £10 note. She gets 30p change. She works out that 1 packet of sausages costs £2.30. Is she correct? Okay, so let's go through this. So first thing I always do in these kind of questions, represent things algebraically. So 2 packets of bread rolls. So we're going to say 2p. So p means, oh wait, no, that's going to get confusing. Let's get rid of that p. Let's represent it as b. So packets of 2 bread rolls plus 1 bottle of ketchup. So we're going to write a K. Plus 3 sausages. So we want to work out how much this is altogether. So the bread rolls are £1.50 each. We have 2 of them. 2 lots of £1.50. That's £3. So we've got a 3 for this. Plus ketchup is £1.60. So we leave it as that. and then the 3 sausages, we don't know how much that is, so we're going to leave that as 3s. We can simplify this. 3 plus 1.6 is 4.6 plus 3s. She pays with a £10 note. She gets 30p change. This means that this thing here, this big amount, if we add 30p to it, we get the total of a tenner. Because when we subtract 30p off both sides, we get this amount, which we're looking for. And then, like it says, Fahima paid with a £10 note, so she's paid with a £10 note, and she's been given 30p in change. So the total is £9.70. So this here comes to £9.70. So we're going to put that down. So 4.6 plus 3 packs of sausages equals £9.70. We're going to just solve for s, and we're going to see if our value of s is £2.30. So first thing we're going to do, we're going to subtract 4.6 from both sides. So 3s equals, so now we want to do 9.7 minus 4.6. 7 minus 6 is 1, 5 minus 4, 9 minus 4 is 5. So we have 3s is 5.1. Now we just want to solve for s. Remember, we can't use calculator, so let's just use the long division. 5.1. How many 3's go to 5? 1. Remainder 2. How many 3's go to 21? 7. So s is £1.70. £1.70. We're going to do a little arrow just so you can see that we've gone from this to there. £1.70 does not equal. Actually, I think I've done that one more around. This sort of symbol about to write means does not equal, because I can't be bothered to write does not equal or doesn't equal. Does not equal. I'm drawing a line through an equal sign because it does not equal. We're crossing out the equal sign. That's what that symbol is supposed to represent. So £1.70 does not equal. So if we actually just write it with pound signs, just so it's a little bit clearer, £1.70 does not equal £2.30. And then just on the safe side, we look back at the question. It says, is Fahima right? So we need to do a little sentence that explicitly says whether or not she is right. So we're going to write Fahima is wrong. I'm going to do a little box around it, just so it's a bit separated from everything else. And that gives you 3 marks. Work out 5/8 times 3/4. Multiplying fractions together, so we just multiply the top numbers together, multiply the bottom numbers together. Can we simplify this first before we do that? 5 goes into 8, no. 5 goes into 4, no. We can't simplify any of that. 3 doesn't go into 8 either. So whatever we're going to get, we're leaving it as it is. 5 times 3 is 15. And 8 times 4, 8, 16, 24, 32. 32. 15, 32. 15 over 32. So that's going to be our answer. 15 over 32. Work out 2/3 subtract 1/4. So we want to get these 2 numbers on the bottom to be the same. What's the lowest common denominator of 3 and 4? That's 12. So we're going to take our 2/3 and we're going to multiply the top and the bottom by 4. Subtract 1/4. and we're going to multiply the top and the bottom by 3/3. And remember, because we're multiplying the top and the bottom by the same number, we're not changing the value of the fraction, we're just making it look different so it's easy to work with. So 2 times 4 is 8. 3/4 is 12. Minus 1 times 3 is 3. 4 times 3 is 12. 8 minus 3 is 5 over 12. And that's our answer, 5 over 12. And I'd imagine you get 1 mark for doing this, and 1 mark for the answer. So 5/12. Let's go to the next question. Oh, this is a 4 marker. It's our first 4 marker. So I'll have a bit of squash because I'm guessing it's going to be a big, there's going to be a lot of talking for it. Sean works for a company. His normal rate of pay is £12 per hour. When Sean works more than 8 hours a day, he is paid overtime for each hour he works over 8 hours. Sean's rate of overtime pay is 1.25 times his normal pay. On Monday he works for 10 hours. Work out the total amount of money Sean earns. This is quite a nice question. In terms of 4 markers, this is quite ideal. So we're going to look at this sentence here. This is the key sentence. When Sean works more than 8 hours a day, he is paid overtime for each hour he works more than 8 hours. He's worked 10 hours on Monday, so we're going to look at the first 8 hours. He's going to get paid his regular amount. So we're going to call his regular amount R, because it is a regular amount. For the next 2 hours, because he works 2 hours extra on top of 8 to get to 10 hours, plus 2, he gets paid 1.25 times his regular amount. So we're going to call this 1.25 lots of R, because it is 1.25 more times his regular pay, and he only works 2 hours more than he's supposed to work in a day. He works 8 hours for regular pay, and anything over 8 hours he's paid overtime pay. He works 2 hours more than overtime pay because he works 10 hours. 10 minus 8 is 2, so he works 2 hours above the 8 hours he gets regular paid for. So the 2 hours he gets paid over, he gets paid this 1.14 regular. The 1.4 multiplied than his normal rate of pay. His normal rate of pay is £12 an hour. So we're going to say that this is 8R plus 2 lots of 1.25 R. So 8 lots of R is 8 times 12. Let's work that out. 8 times 12. We can split this 12 into 10 plus 2. 8 times 10 is 80. Plus 8 times 2 is 16. This becomes 96. So he gets £96 for his first 8 hours. And then he gets 2 lots of 1.25 times his normal rate of pay. Let's work out what 1.25 times his regular rate of pay is. So what's a quarter of his regular pay? So we want a quarter of 12. So we divide it by 4, we get 3. Because 12 divided by 4 is 3. So the quarter is 3. If we add the quarter to his regular pay, so the 1 is 12 and the quarter is 3, we get 15. So when he works overtime, he gets paid £15 an hour instead of 12. So 2 lots of 15. 2 lots of 15 is 30. So we have 96 plus 30. 96 plus 30, 6, 12. Work out the total amount of money he gets paid. I think he gets paid 126. Excuse me a second. Right, sorry about that. Let's go to the question that we're on now. And let's just make sure I have unpaused the footage. I have unpaused the footage. What an ideal outcome. A farmer has 20 boxes of eggs. There are 6 eggs in each box. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. Give your answer in the simplest form. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. Okay, so if we look for 2 boxes, there are 6 eggs in each box. 2 boxes, 6 times 2. So 2 boxes equals 2 times 6 equals 12 eggs. The total number of eggs, so I'm guessing the total number of eggs is the 20 boxes, and if there are 6 eggs in each box, so it's going to be 20 boxes equals 20 times 6 equals 120 eggs. 12 to 120. Well, what we can do, we can just divide both sides by 12. 1, 1, 1, 2, 10. So the ratio, I would say, is 1 to 10. I'm gonna double check that just on the safe side, but I'm pretty sure that is the answer. Right. Okay. So that is correct. So we can carry on with what we were, and I've checked all the other answers, and they've all been correct so far as well. So I'm gonna carry on. The reason I'm checking my answers is just because I am prone to making silly mistakes. So. And that is something I've done before, something I'll do again because I'm a bit daft. So I'm just going to make sure that I don't tell you the silly mistakes that I'm making. So let's go on with the answers. Question 11. A sequence of patterns is made from circular tiles and square tiles. Here are the first 3 patterns in the sequence. How many square tiles do you make pattern 6? So if we look at the square tiles, we have 1. We have 1, 2, 3, 4. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are going up in square numbers, aren't they? Because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. These are going up in square numbers. So if I was to represent the number of square tiles algebraically for each pattern number, because pattern number 1 is 1, pattern number 2 you've got 4, pattern number 3 you've got 9. So I'd say square for square tiles, and I just square it, so that whatever pattern number is, I square it to find the number of square tiles, plus now circular tiles, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 9, 12. So we've got multiples of 4, because we've got 4, then we've got 8, then we've got 12. So I would just say 4C. So this here, this little algebraic expression that I've put, is just a way of easily finding the number of each, and then you can work out the total by adding them together for the total number of tiles. So I just put that as equal to T for tiles. So how many square tiles do we need to make pattern 6? So we take 6, we square it, because this is the instruction that we've worked out as a way of finding the number of tiles. 6 times 6 is 6 squared, which is 36. 36. How many circular tiles do we need to make pattern 20? So again, we can use our formula, but this time we're using this bit. 4 times 20 equals 80. So we can put 80 down here. Derek says when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is Derek right? So let's have a look at our square. So if we have our square here, a square number equals a number times a number. When our square number is odd, we have an odd number times an odd number. An odd number times an odd number is always going to be an odd number. An even times any number is an even. An odd times an odd is always an odd. Even times even is even. So, in fact, I'm going to just write this down here. Even times even equals even. Even times odd is even. Odd times odd equals odd. So when we have an odd times an odd, we always get an odd. So when the pattern number is odd, when the pattern number is odd, we're multiplying an odd number by an odd number to find the number of square tiles, because that's how we've said we found our square tiles. Odd times an odd is an odd. So Derek is right by saying an odd number of square tiles is needed, because when you multiply the pattern number by itself and the pattern number is odd, you're always going to get an odd number. See, for this one here, you've got 1, which is an odd number. For this one here, you've got 9 square tiles, which is an odd number. 5 times 5, 25. 7 times 7, 49. 9 times 9, 81. These are all odd numbers. Odd numbers multiplied by odd numbers always give you odd numbers. Sorry about that. So, when S is odd, an odd times an odd equals an odd. I'm going to put that there just so it's so we can see it's part of our proof. When S is odd, odd times odd is odd. When the pattern number is odd, there. I'm going to type this out and come back to you because this is going to take a dog's age. Right, there we go. So I've put when the pattern number is odd, there will always be an odd number of square tiles, and we've shown that here. When S is odd, odd times odd is odd. We always get an odd number. I might consult I'm going to consult the mark scheme just to see if this suffices, but I think it should suffice. Yeah, okay, so that is fine. Basically what it's saying is, as long as you put something about odd times odd being odd, and then using it and then saying a sentence at the end, you are absolutely fine. So let's go to the next question. 12. There are only 7 blue pens, 4 green pens, and 6 red pens in a box. 1 pen is taken at random. Write down the probability that the pen is blue. Okay, so how many? So we're going to write the number of blue over the total. So what is the probability that there are blue? There are 7 blues over how many is there total? 7 plus 4 plus 6. 7 plus 4 is 11, 11 plus 6 is 17. So our answer is 7 over 17. And I think you should get a mark for this, and you should get a mark for this. Okay, this question I can't really answer because it's about scale and it wants you to measure. So I'm assuming that, so I can tell you how to answer it, but I can't actually do the answer itself. It says the man is of an average height. The tree and the man are drawn to the same scale. Write down an estimate for the real height in meters of the man. So, okay, so this one we can answer. An average man, I would guess, is about 6 foot tall, 5'10". That's we can just guess at 2 meters. In fact, I'm going to check the answers to see if that is correct. Okay, so this question says as long as your answer is in between 1.5 and 2, and we've put 2, so we get a mark. So basically, just guessing how tall the average man is, somewhere between 1.5 meters and 2 meters. Find an estimate for the real height in meters of the tree. So what you would do, you would measure how tall the man is with your ruler in scale. So what I'm going to do, I'm going to put my, actually I can answer this, I'm going to put my ruler, my little Harry Potter ruler, because I'm cool, to the screen and measure how tall our little man is in centimetres. So if I put it to the screen, it says that the man is about 1.1 centimeters tall. So we're gonna round that down. We're gonna say he's 1 centimeter tall. So he is 1 centimeter tall. Then we're gonna measure the tree in height. So the tree is about 6.5 centimeters tall. On my screen, anyway. On my computer screen is 6.5 centimeters tall. So remember this is scale, so we multiply because it's proportion. How do we get from 1? So we say for every 1 centimeter that the man is tall, the tree is 6.5. So we want 2 meters because the man is 2 meters according to our guess. So how do we get from 1 to 2? We multiply by 2. 6.5 times 2, 6 times 2 is 12, 0.5 times 2 is 1, 12 plus 2 is 13, so we're going to multiply that by 2, we're going to get 13. So our estimate is going to be 13 meters, and let me check if that's right. Right, okay, so according to the answers, our scale factor should be somewhere between 5 and 6. I've done it at 6.5. I wouldn't get the mark. So when you actually measure it yourself, let's rub all this out. Let's rub that out as well. It's taking a little while. So we measure our little man, and we get 1. You measure your tree, you get somewhere between 5 and 6. The scale factor is somewhere between 5 and 6. In fact, tell you what, let me answer this question again, but this time I'm going to be absolutely exact. I'm going to be painfully exact. So if I measure the little man, his height is 1.2 centimeters. Okay, so that may be where we're losing our marks. So 1.2 centimeters, and then our tree is 6.4. So our tree is 6.4. So we're going from 1.2 to 6.4. So for every 1.2 centimeters the man is, we have 6.4 for the tree. So how do we get from 1.2 to 6.4? So let's express this as a fraction, and then we can work out our scale factor. 1.2. Actually, I've done that the wrong way around, because we want to work out what we're multiplying 1.2 by to get the 6.4. So we put 6.4 on the top and 1.2 on the bottom. So 6.4 over 1.2. What we're going to multiply both sides, top and bottom, by 10. Just get rid of the just so we can get rid of the decimal places. So this is going to become 64 over 12. We can divide both sides, top and bottom, by 2 because it's. I should make sure I'm recording. I am recording. Perfect. So we're going to have half top and bottom. 32 over 6. Half top and bottom again. 16 over 3. And if we do 16 over 3, just so we can get a rough kind of thing. How many 3 is going to 1? 0. How many 3 is going to 16? 5. Remainder 1. How many 3 is going to 10? 3 remainder 1, and that becomes forever. So our scale factor this time is 5.3, which is a bit more accurate, a bit closer to what we're looking for. So this time we're going to multiply our 5.3. So 5.3 times by our 2 meters, and that gives us 10.6. We're going to put 10.6 meters here. Now that is correct because we're within the range that the answer gives us. Because the answer says that the scale factor must be between 5 and 6, and our answer, because this has to be between 1.5 and 2, our answer has to be between 7.5 and 12. So as long as you measure those things exactly and do what I did, you will get it right. I was a bit lax with my measuring, and because I rounded the man's measurement down, I got the answer wrong. But this answer here, this is correct. So we're going to go on to the next question. Are we? Yes, we are. And this I'm also going to be able to do because I don't have a protractor. I can tell you how to do it. I can give you a rough. Diagram, but I can't do it exactly because, like I say, I do not own a protractor. Is that the right word? Yeah. So 56, 40, 24. So what we're going to do, we need to work out this, because we're going to have something a bit like this, where one of them is French, one of them is Spanish, one of them is German, but we don't know what the angles are going to be. We want to work out how big each of these parts of our pie chart are going to be. So first thing we want to do is work out the total number of students. So 56 plus 40 plus 24. 6 plus 4 is 10, 0 plus 1, 5 plus 4 is 9, plus 2 is 11, plus 1 is 12. So 2, 1, 120. So we have a total of 120. So we want to work out, for every student, how many degrees on this circle will they represent. So we do a little circle here. How many degrees in a circle? 360. So we have 360 degrees divided by 120 students. This gives us 3. So we can cross out the zeros. It's 36 over 12. And that goes 3 times. So, for every student represents 3 degree inclination on our pie chart. So let's put here degrees. So we want to know how many degrees each of these children are going to give us as a total. 56 times 3. So 56 times 3. 50 times 3 is 150. 6 times 3 is 18. That total is to be 168. Which is about there. About that. I mean, like I said, all I can do is be rough. So, as long as you put 168 degrees, in fact, you have to draw it accurately, so you'd have to use a protractor and measure 168 degrees bang on. That's definitely wrong, because I've drawn it rough. But that's all I can do. Spanish, 40 times 3. That is 120. So what you do, where the 0 line is on your protractor, you would you'd put it on. Where's the pen gone? You put it on this line here, and then you'd measure 120 degrees up, and that's going to be somewhere around here, perhaps. And you'd have to say that this angle here is 120 degrees. In fact, that pen's not very clear to see. I'm going to change the colour to this. So yeah, you say that this angle here is 120 degrees, and then just on the safe side, you measure this angle, and it should equal 24 times 3, which I'm going to just tell you anyway is 72. So, and when you add these 3 numbers together, you get 360, because you should anyway. That's also a good thing to double check. So we're going to add our numbers together, 168 120 and 72. 8 plus 2 is 10. 6 plus 2 is 8. 8 plus 7 is 15. Plus our 1 is 16. We do our 1 remainder. What our 1 over. 1 plus 1 plus 1 is 3. So we have 360. So this is how you would do that question using your protractor. Let's go to the next question. Here we go. Year 7 students who asked to study a language. This was their pie chart. The pie chart shows that French was chosen by more Year 9 students at Lowry School than at Halley School. Is Shermina right? You must explain your answer. Pie charts are about proportion. Pie charts show how many people have done something in comparison to another. It does not show quantity, it shows proportion. So, even though this pie chart might be bigger, there might only be 10 kids at Lowry School, and this big thing here might only represent 6 kids. And if we go back to the other one, French was this was French. Actually, that's something I forgot. We can make sure you label your the pie chart, because that's a pretty. I mean, it might be right, but it's not labelled. French, Spanish, German. So even though the pie chart here is smaller, we have 56 kids here. It represents a larger number of kids overall, and this might only have this might only be like 3 and 1. You don't know how many kids there are. You just know that a larger number of people. All you know is that a larger proportion of people at the second school chose French. You don't know how many. You just know that it was more popular with the total number that there are. So we're going to say no. And I'm going to write out an explanation and come back to you in a second. Okay, so this is what I've put. I've put no because pie charts do not express quantity but proportion. So I've said that you don't know how many people there are, you just know how many there are in relation to each other. The answer says something like, because it doesn't give actual figures. That will also do. As long as you say something along the lines of, there aren't exact numbers, so I put do not express quantity. So I put, in fact, I'm going to put quantity of students. Just so it's clear. Quantity of students. And that should be enough to get the mark. Let's go to the next question. Here's a triangle, here's a rectangle. The area of the rectangle is 6 times the area of the triangle. Work out the width of the rectangle. Ooh, this is fun. Right, so we know that the area of our rectangle is 6 times the area of our triangle. How do you work out the area of a triangle? Base times height over 2. So the area of our triangle is 8, because 8 is our base, times 9, because that's our height, divided by 2. Now let's simplify that as 4. 8 over 2 is 4. 9 times 4 is 9, 18, 27, 36. So 36 is the area of our triangle. So we have 6 times 36 is the area of our is our 6 lots of area of triangle. So area of our rectangle is going to be 16 multiplied by our width. We don't know our width, we put it as W because algebra is fun and everyone loves algebra, which is definitely true. So when we equate them, we say that 16 lots of width equals 6. Oh, that's not supposed to happen. No. Oh, damn it. Right. 6 lots of 36. Instead of actually working out 6 times 36, what we can do here, we can just halve both sides and say, okay, half 16 is 8. And let's just halve one of these two things. Half of 6 is 3. Now, let's halve this 8 and it becomes a 4. We can't halve 3 and it becomes a whole number, so we're going to halve our 36 and it becomes 18. Halve our 4, it becomes a 2. Half of 8 is 9. So now we have 2w equals 3 times 9. 3 times 9 is 27. So if we just halve both sides, w becomes 13.5. You can do that using long division. How many 2's go into 20? 1, remainder nothing. How many 2's go into 7? 2, 4, 6, 3. Remainder 1. How many 2's go to 10? 5. Don't forget your decimal point. 13.5 centimeters. Next question. V equals u plus at. Work out the value of v. Okay, so u is 1 plus a, which is minus 3, multiplied by t, which is a half. So this simplifies as 1 plus minus, so minus times a plus is a minus, 3 over 2. Because 3 times a half is 3 halves, 3 over 2, and it's a minus. So what's 1 minus 3 over 2? Okay, so let's make our 1 the same as 2 over 2. Because it's easy to express when we're doing subtraction. 2 minus 3 is minus 1 over 2. V is minus 1 over 2. So, our answer is minus 1 over 2. And we can just leave it as that. Let's go to the next question. Here's a big one. 4 marker. 5 tins of soup have a total weight of 1750. 4 tins of soup and 3 packets of soup have a total weight of 1490. Work out the total weight of 3 tins of soup and 2 packets of soup. Okay, this is a bit kind of unnecessary. Normally these questions will say, "Oh, work out the value of 1 packet of soup." But actually, what I want you to do, apply those numbers and do more multiplication, and it's another opportunity for you to get it wrong, which is a bit harsh as far as I'm concerned. But that's what the question wants, and that's what the question gets. So 5 tins. So remember, we express things algebraically. 5 tins equals 1750. 4 tins plus 3 packets equals 1490. So we need to solve this. So first thing we can do is we can solve for the value of t, because 5t is something, we just divide both sides by 5. So we divide both sides by 5. So let's do that here. 5. So we're looking for 1750 divided by 5. How many 5s go into 1? None. How many 5s go into 17? 5, 10, 15. That's 3. Remainder 2. How many 5s go into 25? 5. How many 5s go into 0? 0. And that's it. Our answer is 350 grams. So the tins are 350 grams. And I'm going to do a little arrow just so the examiners can follow where we've gone. So t is 350g. So what we need to do now, we need to substitute our value of t into this so we can solve for p. So let's do 3. So we're going to do 4 lots of 350. 350 double is 700. 700 double is 1400. So 1400 plus 3p equals 1490. I got that 1400, this 1400 here, just by doing 4 lots of 350, because that's what we've done here. We've substituted our t into here to get 4 lots of 350, and we get 1400. So now we subtract 1400 from both sides. 3p equals, so we're subtracting 1400 from both sides. So not a very good 4. Actually, I'm going to just do that all again because that wasn't very clear. So our answer on the left hand side was 1490, and we're subtracting 1400. 1490 minus 1400, when you do that, you get 90. That's an awful 9. Can I save it? Yeah, I'll do. Right, so P is just 90 over 3, which is 30. So now we have our value of T and our value of P. Normally it would just be like, oh, what's the value of P? But it wants you to actually apply this into a new thing. So we want the total weight of 3 tins of soup plus 2 packets of soup. We have to sub in our values that we've already got. T is 350. 3 lots of 350 plus 2 lots of 30, so 2 lots of 30. 3 lots of 350. 3 times 300 is 900. 50 times 3 is 150. That gives you 1050. Plus 2 lots of 30, which is 60. So 1050, that looks like an 8 or a 6 and definitely not a 5, so I'm going to rub that out and do that again. Nope, not you, I'm going to use the pen. 1050 plus 60. 0 plus 0 is 0, 5 plus 6 is 11, 1 and 1 carries, 1 plus 0 is 1, and then 1. Our grams are 1, 1, 1, 0, and that is our answer for this question. Let's go to the next question. The way the answer wants you to. Okay, so, give me a second. Okay, so, what the question actually, am I recording? I am recording. What the question actually wanted us to do is to focus a bit more heavily on the estimate part of this question. So we get our 10 meters squared. So we can do the same thing again. The area of a circle is pi r squared. We're going to round pi down to about 3 multiplied by 10 squared. Sorry about that. 10 squared is 100, 3 lots of 100 is 300. So we're going to call our area of a circle 300. And then we're going to round our 46 up to 50. So 46, we're going to round that up to 50. And then we're going to say that the number of boxes equals the lawn area divided by the coverage of the box. How the area of the box will cover. So with this 46, we're going to round up to 50. So we've got 300 over 50. That gives you 6. So our estimate is going to be 6 boxes. 6 boxes. Is this an underestimate or an overestimate? So, is this number higher or lower? If it's an underestimate, then our number is going to be bigger. If it's an overestimate, our number is going to be lower. Is it an underestimate or an overestimate? So, our 314, what it should have been, we've rounded down. Our 46, we've rounded up. I'm going to check the answer to see what it says. Okay, so basically the answer says that you just basically kind of work out roughly how would you need more boxes than this. So if we work out the number of boxes that we actually need, 46 times 6, 4 times 6 is 24, 240, plus 6 times 6, which is 36. This gives us 276. This doesn't cover the whole area. This doesn't actually, when you actually work out 6 boxes worth and you multiply out 446 by when you multiply that 46 by 6, you don't cover the whole thing. So, if this is less than what we need, we need it to be bigger, therefore 6 is an underestimate. Not very clearly written, but you get the gist. Basically, we've worked out our estimate says it is 6. However, we need more than 6. So we have underestimated the number of boxes we need. We need more than 6. That's basically just the gist of it. Okay, here we go. Solve this. 4 brackets x plus 5 is 18. So let's divide both sides by 4. 18 divided by 4 is the same as 9 over 2. Or just 4.5. So x minus 5 is 4.5. X equals 9. Sorry, I'm going to start that over because I went through that too quickly. First thing we do is divide both sides by 4. That clears, and we're left with x plus 5, minus 5, sorry, equals 18 over 4. How many 4s go into 1? 0. How many 4s go into 18? 4, 8, 12, 16, 20. We're above 18. We go back 1. 4. We have 4 with a remainder of 2. How many 4s go into 20? Bang on 5. So x minus 5 is 4.5. We add 5 to both sides. We add 5 here. We add 5 here. 4.5 plus 5 is 9.5. That's our answer. X is 9.5. Oh, that's odd. Why is there a TM? T is an integer. Right, I'm going to check. I'm going to see what that question's supposed to look like, and I'll come back to it in a second. Okay, what the question's supposed to look like, my apologies, is minus 3. No, in fact, I think I've copied down. I think it's supposed to look like minus 3 is less than x, which is less than or equal to 2. Yes, that is correct. So, if we're looking for numbers in between minus 3 and 2, so let's write them all down. Minus 3, minus 2, minus 1, 0, 1, and 2. X is less than 3. It does not equal 3, it's less, sorry, x is great, minus 3 is less than x. It's not less than or equal to, it's just less than. We don't include the minus 3, so we cross out the 3. X is less than or equal to 2. It equals 2, so we leave it in. Remember, t is an integer. Sorry, this is supposed to be a t, not an x. That's my bad. Let me just knock that out. T. So, minus 3 is less than t, which is less than or equal to 2. And they're integers, but integers are numbers. So these are the 5 numbers we can actually have. Minus 2, minus 1, 0, 1, 2. Asmol is paid £1,500 a month. He's going to get a 3% increase on the amount of money he's paid. That is good news for Asmol. Work out how much money Asmol will be paid per month after the increase. 3% increase. Same as 1.03 multiplying by. Or we can just work out what 3% is, add it to the 1,500. Because a 3% increase, so he gets paid 100% anyway, because that is just the default amount. He gets paid 3% extra, so he's going to get paid 103%. We don't have a calculator, we can't just put it in the calculator, we have to work it out. So, if 100% equals 1,500, 10% is 150, 1% equals 15. We can work out 3% by multiplying 15 by 3, because 1% times 3 is 3%. We've done a multiplication of 3 to get to this point. Times 3, which equals 45. So we add our 1500, which is our 100%. We have our 45, which is our 3%. We add them together, and we get 1545. That is our answer, 1545. And there is our answer. Let's move on to the next question. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. One of the points is an outlier. Write down the coordinates of this point. So an outlier is an anomaly. It is something that doesn't follow the pattern, an outlier. So which one of these doesn't follow the pattern? Well, it's a bit obvious, it's the one that is not in line with it. These all kind of go down that kind of line, don't they? Apart from this one. So let's get the coordinates down. We go down halfway between 9 and 11, that's 10. We go across halfway between 18 and 20 is 19. So our x coordinate is 10, our y coordinate is 19. For all the other points, write down the type of correlation. So there are 3 types of correlation: positive, negative, and none. A positive correlation is when as the x gets bigger, the y gets bigger. A negative is as an x gets bigger, the y gets smaller. And if there's no correlation, the dots are just madness and they're random. So, for positive, as the x gets bigger, the y gets bigger. Negative, as the x gets bigger, the y gets smaller. And if there's no correlation, they're all just hella random. And that's right, I just said hella in a maths video because I'm cool. Let's have a look. So as we go across, as these numbers become bigger, we're going up. See how these kind of follow that kind of direction? As the x gets bigger, the y also gets bigger. So we have a positive correlation, and that is that type of correlation, and that is that question answered. Let's go to the next one. Okay. On the same day, in another British town, the maximum temperature was 16.4. Estimate the number of hours of sunshine on this day. 16.4. So, if we just rub off all our things, and then we just do a little line. We do a line of best fit. So what does it say? 16.4, which is gonna, which if we use these little things to work out where 16.4 would be, there is 14. Here is 16. There are 5 thinner lines between each thick line, so each gap is 0.2. So 16.4 is here. We go up and up and up and up and up and up and up until we reach here. Oh no, I just done this wrong. I've absolutely done that wrong. That's my bad. Okay, so let's rub this out. Let's go again. So what I'm actually meant to say was the maximum temperature over here, 16.4, which is about here. We go across and then we go down about, that's not a very straight line, but it does come from, let's try and rub that, oh damn it, I'm going to have to do it all again. Right, 16.4 to about here. So remember, so 17 is here, there's 5 little thinner lines between each thick line, so each little thing's worth 0.2, so 0.2, 0.4, we go across from 0.4, let's try and stick to the line, there, we go down, we follow the line, and I am trying to be exact as that way, working about there, which is 12.8. An estimate 12.8. And you don't need to worry about working out because the lines you did on the graph are the working out. Temperature is higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? The answer is yes. That's fine. As I said, I'm allowed to be wrong. Yes, because the graph basically just shows as temperature as because as there is more sunshine, that's an N. As there is more sun, temperature goes up as well. I can't bother to write the whole thing, but you get the gist of it. Express 56 as the sum of prime factors. This one I can do. 56 becomes 2, and half 56 you get 28. 2. Half this you get 14. 2. Half this you get 7. We've only got prime numbers left. 2 times 2 times 2 times 7. So we have 2 times 2 times 2 times 7. Work out 54.6 times 4.3. Right, okay, so 54.6 multiplied by 4.3. Multiply. Okay, so let's start off with the 0.6. In fact, I'm going to get rid of this bottom line. So 0.6 times 0.3. 6 times 3 is 18. But we're behind the lines, so this becomes 1/8. We're not multiplying up, we're multiplying down. It's a point something times by a point something. So this number becomes smaller, times 3 becomes 18. But it gets smaller, so it's 0.18. 0.6 times 4, 2.4. Now we've done this one, we're going on to this one now. So 4 times 0.3 is 1.2. 4 times 4 is 16. We've done that one. Now we're on to the 5, or 50. 50 times 3.3 is 15. 50 times 4 is 200. Now we sum all these things together. And the only thing in this column is an 8, so we just go to 8. 1 plus 4 plus 2 is 7. We go to the point. 2 plus 1 is 3. 3 plus 6 is 9. 9 plus 5 is 14. 4, 1. 1 plus 1 is 2, plus the 1 is 3, 2. Our answer was 234.78. A lot of those multiplications that I did do quickly, you can do yourself. So let's do the 0.6 times 0.3. A nice way of doing that is by just timesing this by 10, timesing this by 10, and now you've got 6 times 3, and this gives you 18. But to get to our original thing, we have to go back. We have to divide by 10. Dividing by 10 twice is the same as dividing by 100. So we have 18 divided by 100, which is 0.18. So that's a nice way of doing that. And basically just for every one of these things, separating them out into this kind of sum. So 0.6 times 0.3. The next one was 0.6 times 4. So we write 0.6 times 4. Again, we times this by 10. We get 6 times 4, which is 24. No, that's. But to get from 6 to 0.6, we divide by 10. We divide that by 10. We get 2.4. Okay, let's go on to the next question. Show that the area. Ooh, I like this question. Okay, so the area of square ABCD now is 10 centimeters squared. Show that the area of this is that. Right, so the area of a square is the width squared. The width is x plus 3. x plus 3 squared, because it's the area of a square. We square this, so we have x plus 3, x plus 3, x times x squared, x times 3, 3x, 3 times x, 3x, 3 times 3, 9. We can tidy this up, and we can be like, okay, x squared, 3x plus 2x is 6x, plus 9. It says the area of the square is 10. We just worked out the area of the square, but we worked it out algebraically. So we can equate our little thing here. I'm just going to make that x easy to write. We can equate this to 10. So we now have x squared plus 6x plus 9 equals 10. Right, we want this as x squared plus 6x only. We don't want the numbers on the left hand side. So let's subtract this 9. 9 minus 9 is 0. 10 minus 9 is 1. X squared plus 6x equals 1. And that's what we were looking for. That's what we were looking for. So now we're done with that question. The rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the frame, and the metal in the frame. So we have 5 straight pieces of metal. 1, 2, 3, 4, and 5. We can work out the total length of the perimeter, and then we're going to add this diagonal line. So 12 plus 5 plus 12 plus 5. The perimeter of a rectangle. The rectangle is 2 width plus 2 length. 2 lots of 12 is 24. 2 lots of 5 is 10. This gives us 34. Now we need to work out the diagonal. The diagonal is just Pythagoras. We want to do the square root of 12 squared plus 5 squared. If we go across, we're going to find that 12 squared, same as 12 times 12. 12 times 10 plus 2. 12 times 10 is 120. Plus 2 times 12, which is 24. Which gives 144. So our 12 squared is 144. 5 times 5 is 25. We add these together, we get the square root of 169. You want to find a number that when you square root it, you get 169. This is a non-calculator question, so that square root is not going to be a decimal because you wouldn't be able to find it without a calculator. So if we do 12 times 12, we've got 144. Let's go up, let's just see what the next square number up is. So let's do 13 squared, let's work that out. So 13 times 13, or 13 times, so that's supposed to be a times, I will change that to a more easy to read, times 10 plus 3. 13 times 10 is 130. 13 times 3 is 39. Add these together, and voila, we get 169. Funny that. So this equals 13. So we can add 13 to our perimeter, and we now get 47. Because we've done 12 plus 5 plus 12 plus 5 plus 13. And that has given us 47. The weight of the metal is 1.5 kilograms per meter. We have 47 meters. So we do 47 multiplied by 1.5, which equals 47, times 1 plus 0.5. So we're going to add 47, and then we're going to halve 47. 47 times 1 is 47. 47 halved is going to be 23.5. I'll show you up here. 247. How many 2's going to 4? 2. How many 2's going to 7? 3 remainder 1. Sorry, that's 0, and the 1 goes up here. How many 2's going to 5? How many 2's going to 10? 5. There's our answer. So we're going to add 47 and 23.5. 47, 23.5. 5 plus 0 is 5. 7 plus 3 is 10. 4 plus 2 is 6 plus 1 is 7. So our weight is going to be 70.5. That is the answer to that question. That was quite long-winded, went on for days, but we've gotten to our end, we've gotten to where we want to be. Right, okay, let's carry on. The equation of the line L1 is that, the equation to the line L2 is that. Show that these lines are parallel. Is this the last question? No, we have one more, and then that's it. No, 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 I don't want to. No, go away. Keep. No, don't exit the slide. You've exited the slide. That's annoying. Right, okay, so let's get back to this one. And we've got to go through again. All the way through all the work we've done, and we get to here. So what we want to do, if we're proving that they're parallel, remember y equals mx plus c. If they're parallel, the gradient is the same. We want to show that this m value is the same when these two lines are expressed in the same way. So we have y equals 3x minus 2. The thing we're interested in is 3. When we rearrange this here, we want to be able to get y equals 3x plus or minus something or other. I don't know. Let's find out. So let's have a look at 3y minus 9x plus 5 equals 0. Let's bring these x business onto the other side. 3y equals, we add 9x to both sides, 9x, we subtract 5 from both sides, minus 5. If we divide our y by 3, because we want to get it in the form of y equals, we divide this by 3 as well. 3y minus 3 is y. 9x divided by 3 is going to be 3x minus 5 over 3. See, we have our x values as the same. Gradient in both. That's an awful way of me trying to say both. Gradient in both lines are equal, therefore parallel. That, take my word on it, that's parallel. And the 3 little dots I've done here, that means therefore. I can't be bothered to write the word therefore, so I just write it as 3 little dots. In the shape of a triangle, 3 little dots, that means therefore. I'll save you a bit of time when you're doing these little proofs. Let's go to question 27, which is the last one. ABCD is a parallelogram. The diagonals intersect at the origin. AO equals A, AOB equals B. Find, in terms of B, the vector DB. So, because this is a parallelogram, DO is going to equal OB. So we're going from D to B. So this here is the same as that, which is B. So we have B plus B, which is 2B. Find, in terms of A and B, the vector AB. So we're going from here to there. Let's rub out this here. So we're going from there to there. We don't have a way of expressing that. So we go down to here. We find the shortest route. We go down to here and we go up to there. Vectors have direction. So if the little a points towards A, we're going back from A. That becomes minus A. This direction is A, this direction is negative A. So we have a negative A, and then we have our regular B, plus B. So you can write minus A plus B, or you can just write B minus A. Find in terms of A and B the vector AD. So let's report that again. Let's go through this question. AD, so we're going from here to there. So we go against the grain from minus A. We go A to 0. AO is A, so AO, because we're going backwards, equals negative A. We said that going from here to here gave us B. We're going backwards, we want negative B now. So we want minus A minus B. Or we can express this as minus A plus B. So we've done we've done a negative A, we've done a negative B, but the negative out is a common factor. You can write it as either minus A minus B or minus brackets A plus B. And that is the whole paper. It was a bit of a rough road getting from the beginning to the end, but we're there. I think they're all right. I will double check now. If some of them aren't right, we're going to go back through and correct them, but I'm pretty sure they're all right. So let's, I'm going to check that now and come back to you in a second. Okay, so, yeah, that was all fine. Everything was correct there. I hope you followed all that. If there are any questions that you want me to go over again, comment them down below in the comments area. I will go through it again in a separate, shorter video. Well, it'll be a better explanation, but it will be a shorter video overall, because this video has been going on for ages. Anyway, thank you for watching. I'm sorry the live stream didn't work. I will get on to doing the answers for homework 3 pretty sharpish. Thank you for watching, and I'll see you soon.